The two parallel and coplanar shafts are connected by gears having teeth parallel to axis of the shaft. This arrangement is known as spur gearing. The arrangement is called bevel gearing when two are connected by gears intersecting and coplanar shaft. When two non-intersecting and non-coplanar shafts are connected by gears, the arrangement is known as helical gearing. This is the wrong. The gearings are termed as a medium velocity gears if their peripheral velocity is 3 minus 15 by meter per second. An imaginary circle which by pure rolling action gives the same motion as the actual gearing is the pitch circle. The size of gear is usually specified by pitch circle diameter. The radial distance of tooth from the pitch circle to the bottom of the tooth is called dedendum. The addendum is the radial distance of tooth from the pitch circle to the top of the tooth. Agree. The working depth of a gear is radial distance from the addendum circle to the clearance circle. The radial distance from the top of the tooth to bottom of the tooth is meshing gear is called as clearance. The face of tooth is the surface tooth above the pitch surface. The flank of the tooth is the surface of the tooth. The pitch surface is below. The ratio of the number of teeth is pitch circle diameter in millimeters is called diametral pitch. The tooth of the pitch circle diameter in millimeter, the number of teeth is called circular pitch is the no. The product of diametral pitch and circular pitch is equal to pi. The product of the diametral pitch and model is equal to 1. Correct. The model is the reciprocal of diametral pitch. True. The dedendum circle diameter is equal to pitch circle diameter into cos pi. The contact ratio is the ratio of length of arc of contact to the circular pitch. According to the law of gearing, the common normal at the point of contact between the pair of teeth must always pass through the pitch point is S. The velocity of sliding, the distance of the point of contact from the pitch point is directly proportional to. Involute gear, the pressure angle is always constant. In full depth 1400 involute system, the smallest number of teeth is a pinion which meshes with the rack without interference is 32. The minimum number of teeth on the pinion which will mesh with any gear without interference for 20 degrees full depth involute teeth will be 18. The pressure angle of involute gears depends upon the size of teeth. This is the wrong. The contact ratio is given by length of the arc of contact by circular pitch. For an involute gear, the ratio of base circle radius and pitch circle radius is equal to cos pi. Which of the following statement is the correct for gears? All of this above. In a gear having involute teeth, the normal to the involute is tangent to the base circle. The center distance between the two meshing involute gears is equal to sum of base circle radii by cos pi. When the tip of tooth undercuts the tooth, the root of its mating gears is known as interference. Agree. In gears, interference takes place when the tip of tooth of mating gear digs into the proportional between the base and root circle. An involute pinion and gear are in mesh if both have the same size of the addendum. There will be interference between the tip for the gear tooth and flank of pinion. Which of the following statement is correct for involute gears? The pressure angle is constant throughout the teeth engagement. The interface may only be avoided addendum circle of two mating gears cut the common tangent to the base circle between the point of tangents. This is the true. When the addenda on a pinion and wheel in such that the path of approach and path reaches the half of for this maximum possible values, then the length of the path is contact given by r plus r sin pi by 2. The maximum efficiency of a spiral gear is cos theta plus pi plus 1 by cos of theta minus pi plus 1. The contact ratio for gears is dash greater than 1. In a simple train of wheels, if the number of intermediate wheels is odd, the motion of the follower will be same as that of the driver is s. In a simple train of wheels, the velocity ratio the intermediate wheels is dash is independent of. The train value of gear train is dash reciprocal of velocity ratio of a gear train. When the axis of the first and last wheels are coaxial, then the train is known as riveted gear train. The gear train usually employed in a clock is dash riveted gear train. Which of the following statement is correct? All of this above. The axis of precession is the plane of the which takes place of the spine is going to rotate dash perpendicular. A disk is a spinning with a angular velocity omega radian per second above the axis of the spin. The spin the couple applied to the disk causing precession will be dash I omega p. The engine of an aeroplane rotates clockwise direction when seen from the tail and the aeroplane takes turn to the left. The effect of gyroscope couple on the aeroplane will be dash to raise the noise and dip to the tail. The engine of aeroplane rotates clockwise direction when the seen from the tail and the aeroplane takes turn to the right. The effect of gyroscopic couple the aeroplane will be dip nose and raise the tail. This is the correct. The steering of ship means turning of complete ship in a curve towards right or left while it moves forward. The rolling of a complete ship sideways is known as a pitching of the ship. This is the false. The rotated of a ship rotates in a clockwise direction. The viewed from the stern and ship takes place. The left turn, the effect of gyroscopic couple acting on it will be dash to raise the bow and lower the stern. The rotor of ship rotates in a clockwise direction when viewed from the term and the ship takes right turn. The effect of gyroscopic couple acting on it will be raise the stern, lower the bow. Agree. The pitching of ship is azimuth to the takes place of a simple harmonic motion. This is the yes. When the pitching of the ship is upward, the effect of gyroscopic couple acting on it will be dash to move the ship towards starboard. When the pitching of ship is the effect of gyroscopic couple acting on it will be move the ship towards port side. This is the downward. The pitching of ship produces forces on the bearings which acts as the motion of the ship is dash horizontally and perpendicularly. The maximum gyroscopic couple acting on the ship tends to shear holding down poles. This is the correct. A motor car moving a certain speed takes a left turn is curved path. In the engine rotates the same directions as that of wheels. That due to centrifugal force, the reaction of the outer wheels increases and the inner wheels decreases. The inertia force is equal accelerating force magnitude but opposite direction is that. The velocity of piston in a reciprocating steam engine given by omega r sin theta plus sin 2 theta by n. The acceleration of piston reciprocating steam engine is given by omega square r cos theta plus cos 2 theta by n. The displacement of the piston of a reciprocating steam engine when the crank has moved from inner dead center through the angle theta is given by r of 1 minus cos theta plus sin square theta by 2n. When the crank at the inner dead center is reciprocating steam engine, then the velocity of the piston will be dash 0. When the crank is the inner dead center as reciprocating steam engine is then the acceleration of piston will be dash omega square r n plus 1 by n. When the crank is at the outer dead center is reciprocating steam engine, then the acceleration of the piston will be dash omega square r n minus 1 by n. In reciprocating steam engine, when the crank has turned from inner dead center through angle theta, angular velocity of a connecting rod is given by dash omega cos theta by n square minus sin square theta by 1 by 2. In a reciprocating steam engine, when the crank has turned from inner dead center through the angle theta, and angular acceleration of the connecting rod is given by minus omega square sin theta n square minus 1 by square minus sin square theta 3 by 2. The Klein's diagrams is useful to find acceleration of various spots. Thrust on the side of cylinder walls is the A Fb by cos pi. Force acting along the connecting rod B is the Fp into tan pi. Thrust on the crankshaft B is the Fp by cos pi into cos of theta plus pi. Torque on the shaft bearing is the Fp sin p plus cos theta tan theta into r. Crank pin efforts is the Fp by cos pi into sin of theta plus pi. The Klein's diagram is used when dash crank has uniform angular velocity. The Klein's method of a construction for a reciprocating engine mechanism utilizes a quadrilateral similar to the diagram of mechanism of reciprocating engine. In the figure shows we see connecting rod is this is the diagrams which is omega square into Cn. In the above equation of n coincident with n is the acceleration of the piston, p is 0 and the velocity is maximum. And the acceleration of the piston 0 will crank is connecting rod PC are right angles to each other. This is the correct. A rigid body under the action of frictional forces can be replaced with two masses placed by the fixed distance apart. Two masses from the equivalent dynamical system is dash all of the above. The essential condition of placing the two masses so that the system becomes a dynamically equivalent is dash L1 L2 is equal K square G. The length of tangent delta simple pendulum which gives the same frequency as compound pendulum is dash K square G plus L square by L1. In 4-stroke IC engine, the turning moment of during the compression stroke is dash negative throw. The maximum evacuation of energy is the dash difference between the maximum and minimum energies. The coefficient of fluctuation of energy is the ratio of maximum energy the minimum the wrong. The maximum fluctuation of a speed is the dash difference of the maximum and minimum speed. The coefficient of fluctuation of the speed of the maximum fluctuation of the speeds the speed and the mean speed is dash. This is the ratio. In a turning moment diagram, the variation of energy above the below the mean resistance torque line is called as fluctuation of energy. Which of the following statement is wrong? This is not visible. The ratio of maximum fluctuation of energy to the work done per cycle is called coefficient of fluctuation of energy. The ratio of maximum fluctuation of speed to the mean speed is called this is a coefficient of fluctuation of speed. Maximum fluctuation of energy the flywheel is equal to all of this above. A flywheel is fitted to the crankshaft of an engine having W an amount of indicated work per revolution and permissible limits the coefficient of fluctuation of energy and speed CE and CS respectively. The kinetic energy of the flywheel is given by WCE by 2CS. If the rotating mass of a trim type flywheel distributed and another trim type flywheel was mean radius of half the mean radius of the former, then energy stored in the latter of the same will be dash 1/4 of the first one. In steam engine, the distance of which outer edge of the D slide value overlaps the steam port is called this is the steam lap. In a steam engine, the distance by which the inner edge of the D slide valve overlaps the steam port is called as the degree. The displacement of the D slide valve is the steam lap by a distance known as lead of the lead valve. This is the greater than. The D slide valve is also known as outside admission valve. The piston slide valve is an inside admission valve with the S. The distance by which the D slide valve overlaps the steam point is called as the exhaust is inner edge. Which of the following statement is correct? All of this above. The distance moved by the valve from one end to the another end is called the valve travel. This is the true. The throw of the eccentric is equal to the valve travel is the incorrect. In a steam engine, one method of obtaining the earlier cutoff with a simple slide valve is increasing the angle of value advances of the eccentric while the throw of the eccentric steam lap and exhaust lap are kept constant. This method will be dash reduced length of effective stroke of pistons. In a steam engine, the earlier cutoff with a simple slide valve may be obtained by increasing the angle of advance of the eccentric but reducing the throw of the eccentric, the keeping at the steam lap and exhaust lap constant. This method will be causes withdrawing or throttling of steam. This is the agree. In a steam engine, the earlier cutoff a simple slide valve may be obtained by increasing and steam lap and the angle of advances of eccentric but keeping constant travel and level of the valve. This method will be reduces maximum opening of the piston steam. In Mayer's expansion value, the main value is driven by an eccentric having an angle advanced from the 25 to 30 degrees. The virtual or equivalent eccentric for Mayer's expansion value is defined as an eccentric having such a length and angle advance that will be cut off takes place the same position as caused by combined effect of a main eccentric and expansion eccentric. This is the right. In Mayer's expansion value, the expansion value is driven by the eccentric having the angle of advance from this. This is the 80 to 90 degrees. The function of reversing gear is the steam engine is dash to alter the point of cutoff wheel engine is running. When the load on the engine increases, it becomes necessary increases supply of the working fluid, and when the load decreases, less working fluid required. The supply of the working fluid to the engine is controlled by dash governor. A flywheel is used to control the mean speed of the engine caused by the variation is load. This is incorrect. Which of the following is caused to control the speed variation of the engine caused by the fluctuation of the engine turning moment? This is the flywheel. The height of Watt's governor is equal to 895 by n square. The height of the Watt governor is dash inversely proportional to speed square. A Watt governor can work satisfactorily at speeds from dash 60 to 80 rpm. The ratio of height of Porter governor length or to height of the Watts governor is dash m plus m by m. When the sleeve of a Porter governor moves upward, the governor speed is dash increases. When the sleeve of a Porter governor moves downwards, the governor speed is dash decreases. In a Proel governor, the balls are attached to the extension follower line is true. Hornell governor is dash spring loaded governor. A Watt governor in a spring loaded governor, this is the no. Which of the following is pendulum type governor? This is the Watt governor. In a Hornell governor, the left of the sleeve is given by R1 minus R2 y by x. In a Hornell governor, the compression of the spring is the left of the sleeve. This is the equal to. In a Hornell governor, the stiffness of the spring is given by S1 minus S2 by H. Which of the following is a spring controlled governor? This is the all of this above. A pendulum type governor is Watt governor. This is the agree. A Porter governor is dash deadweights governor. Which of the following governor is used to drive gramophone? This is the Pickering governor. And the sensitivity of the governor depends upon the lift of the sleeve. This is the right. For two governors A and B, lift of sleeve for governor is more than that of the governor is given fractional change speed indicates the dash. Governor A is more sensitive than the governor B. The sensitivity of the governor as the speed ranges decreases dash increases. Sensitivity of the governor is defined as the ratio of the difference of maximum and minimum equilibrium speeds of the mean speed. A governor is said to be stable if the dash radius of rotation of balls increases at the equilibrium with speed increases. When the radius of rotation of a balls as the equilibrium speed increases, the governor is dash is said to be unstable decreases. A governor is said to be isochronous when range of speed 0 for all radius of rotation of the balls within the working range neglecting from this is the S. A Porter governor cannot be isochronous. This is agree. In a Hornell governor of a spring of greater stiffness is used, then the governor will be dash less sensitivity. When the speed of the engine fluctuates continuously above and below mean speed, the governor is said to be dash hunt. A very sensitive governor will cause hunting. This is the true. For an isochronous Hornell governor is mg plus s1 by mg plus s2 by equal to r1 by r2. Effort of governor is dash mean force exerted at a sleeve for the given percentage change of speed. Power of a governor is the dash none of the above. The effort of Porter governor is equal to C of m plus m into g. The power of Porter governor is equal to 4c square by 1 plus 2c m plus m into gh. For the isochronous Porter governor, the controlling force curve is the straight line passing through the origin is the correct. The controlling force diagram for a spring controlled governor is curve passing through the origin is the no. A spring controlled governor is said to be unstable when the controlling force decreases, the radius of the rotation increases. In a spring controlled governor, when the controlling force has the radius of the rotating increasing, is said to be stable governor. This is the increases. A spring controlled governor is said to be isochronous when the controlling force is remains constant for all radial rotation. A spring controlled governor is found unstable. It can be stable by decreasing the spring stiffness. A spring controlled governor is said to be stable. The controlling force line when produced intersect the y-axis is the below the origin. If the controlling force line for a spring control governor when produced intersect y-axis or the origin, then the governor is said to be dash isochronous. If the controlling force line for a spring controlled governor when produced intersecting y-axis above the origin, then the governor is said to be unstable. This is the rate. The relation between the controlling force of a radius rotation stable spring controlled governor is dash Fc equal to AR minus B. In a spring controlled governor is said to be unstable. The relation between the controlling force and the radius of the rotation Fc is equal to AR. This is the I disagree. When the relation between the controlling force Fc radius of radiation or of spring controlled governor Fc is equal to AR plus B, then the governor will be dash unstable. A Hornell governor has its a controlling force given by Fc is equal to AR plus B, where R is the radius of rotation and A and B are constant. The governor becomes isochronous when dash A is positive and B is 0. The brake commonly used in the railway trains is shoe brakes. The brake commonly used in the motor cars is internal expanding brake. This is the true. In differential brand brake shown in the figure, the drum rotates clockwise and the greater than dimension T1 and a smaller tension T2, length OA greater than the length of B, order apply brake force P at C should dash. ఈ విధంగా ఉన్నప్పుడు ఏం చేయాలి? యాక్టింగ్ డౌన్వర్డ్స్. ఇన్ డిఫరెన్షియల్ బ్యాండ్ బ్రేక్ షోన్ ఇన్ ద అబోవ్ ఫిగర్ ద లెంత్ ఓబీ greater than OA, then the force P at C should be in the downward direction. This is no. For the brake to be self-locking, the force P at C shown in the figure Q should be dash. This is the B0. When brakes are applied to the four wheels of moving car, distance traveled by the dash car before he is using brought to rest will be dash minimum. A band and block brake is the ratio tension on tight side crank side of the band is dash T1 by T2 1 plus mu tan theta by 1 minus mu tan theta all power of n. The absorption type of dynamometer is the slow brake dynamometer. The transmission type dynamometer is dash epicyclic train dynamometer. The size of cam depends upon base circle. Pitch point of a cam is dash point on the pitch curve having maximum pressure angle. The pressure angle of a cam is the angle between the direction of the follower's motion and the normal to the dash pitch curve. If the pressure angle is dash, reciprocating followers will jam its bearings if too large. In cam drive with uniform velocity follower, sharp corner to displacement diagram are rounded off the beginning and end of the each stroke. This done is dash in order to have acceleration in beginning and retardation at the end of stroke within the infinite elements. The cam follower generally used in automobile engines dash spherical forced followers. The cam follower generally used in aircraft engines is dash roller followers. In a radial cam, the followers moves dash in direction perpendicular to the cam axis. For low and moderate speed engines, cam followers should have moved the simple harmonic motion. For low and moderate speed engine, cam followers should move with the simple harmonic motion. For high speed engines, the cam followers should move with the dash cyclodal motion. The displacement of the reciprocating roller followers when it's the contact with the straight line of the straight flanks of the tangent cam is given by dash R1 plus R2 1 minus cos theta by cos phi. The velocity of the reciprocating rollers follows when the constant contact with the straight flanks of the tangent cam is given by dash omega R1 plus R2 sin theta cosecant phi theta. The acceleration of the reciprocating roller followers when its contact with the straight flanks of the tangent cam is given by omega square R1 plus R2 2 minus cos square theta by cos cube theta. The displacement of flat-faced followers when its contact with the flank of a circular arc cam is given by dash R minus R1 1 minus cos theta. The velocity of flat-faced followers when its contact with the flank in the circular arc cam is given by dash omega R minus R1 sin theta. The acceleration of flat-faced followers when it has contact with a flank is circular arc cam is given by omega square R minus R1 cos theta. The retardation of a flat-faced followers when is contact the apex of the nose of circular arc cam is given by omega square into OQ. In a circular arc cam with a roller followers, the acceleration in any position of the left will depends well, this is the total left, total angle lift, minimum radius of cam and speed. Balancing of rotating and reciprocating parts of a engine is necessary when it runs at the high speed. A distributing mass M1 attached to the rotating shaft may be balanced by a single mass M2 attached in the same plane rotation as that of M1 is such that M1 R1 equal to M2 R2. For static balancing of shaft, net dynamic force acting on the shaft is equal to 0. Agree. For dynamic balancing, is a shaft is both A and B. A rotor supported A and 2 masses shown in the figure. The order statically and dynamically balanced. A system of masses rotating in different parallel planes and dynamic balance of the dash. Resultant force and resultant couple are both equal to 0. Which of the following can completely balance several masses revolving different planes on the shaft is two masses in any two planes. A system dynamic balance implies that the system is also statically balanced. Which of the following statement is correct? If rotor statically balanced, it may or may not be dynamically balanced. Remains same as the before. Rotor which have balanced statically but not dynamically supported bearings really apart and a high speed of rotor reaction on the left bearing or right side of the bearing shifted new position 2L part from the left bearing at the same rotor speed. Dynamic reaction of the left bearing in the new arrangement will be remain same as before. The static balancing is satisfactory for low speed rotors, but in increasing speeds dynamics balancing becomes necessary. This is because the effects of unbalance are proportional to the square of the speed. The balancing of a rigid rotor can be achieved by properly balancing masses. This is the two planes. The primary unbalanced force due to inertia reciprocating parts of reciprocating engine is dash m omega square or cos theta. The secondary unbalanced force due to inertia of reciprocating parts of reciprocating engine is given by m omega square or cos 2 theta by n. The secondary unbalanced force is the primary unbalanced force 1 by n times. The primary unbalanced force is more than the secondary unbalanced force is true. The primary unbalanced force is maximum when the angle of inclination of the crank with the line of stroke is dash 0 and 180 degrees. The secondary unbalanced force is maximum when angle of inclination of the crank with the line of stroke is dash both A and B 0 and 90 180. The primary unbalanced force is maximum in one revolution of the crank is twice. The primary unbalanced force of reciprocating mass is inversely proportional to the crank's radius. This is the no. The secondary unbalanced force is maximum in one revolution of the crank is 4 times. The unbalanced force due to reciprocating masses, this is the various magnitude but constant direction, various 2 times 2 is the correct. The unbalanced force due to the revolving masses, various magnitude but constant in various in direction but constant in magnitude. In order the balance of the reciprocating masses both A and B. Most of the engines generally do not require balancing of secondary forces and couples. This is right. The partial balancing means this is the balancing partially reciprocating masses. The unbalanced primary forces in a reciprocating engine are dash balanced partially. In a reciprocating engine, usually of the reciprocating mass are balanced two-third is there. And again, in order to the facilitate starting a locomotive in an locomotive position, the cranks of a locomotive with two cylinders are placed at 90 degrees to each other. The partial balancing reciprocating parts in locomotive produces all of this above. A locomotive, the ratio of the connecting rod length to the crank radius is kept very large in under 2 dash minimize the effect of secondary forces. And the attractive force in locomotive with two cylinders is given by 1 minus e m omega square or cos theta minus sin theta. The transverse force is maximum minimum when the angle of inclination of a crank with the line of stroke is equal to 90 and 180. The maximum and minimum value of the transverse force is given by plus or minus root 2 1 minus e m into omega square into r. The swaying couple is due to dash primary unbalanced force. The swaying couple is the maximum or minimum when the angle of inclination of the crank to the crank to the line of stroke. Crank to the line of stroke is equal to 45 to 225 degrees. The maximum or minimum value of swaying couple is dash plus or minus a by root 2 1 minus c m omega square r. In a locomotive, the maximum magnitude of unbalanced force along with a perpendicular to the line of stroke is known as, this is the hammer blow. In a locomotive, the result unbalanced due to the two cylinders along the line of stroke is known as tractive force. The effort of swaying couple is locomotive is restricted by the side pressure between the flange of the type of the wheel and inside of the rail. This is the effect of hammer blow in a locomotive can be reduced by 2 is there, decreasing the speed using 2-3 pairs wheels coupled together. Which of the following statement is correct? The primary unbalanced force maximum twice in one revolution of the crank. The magnitude of the swaying couple in a locomotive is inversely proportional to the distance between two cylinders' center lines. In order to give the primary balance to the reciprocating parts of a multi-cylinder inline engines dash both A and B. In order to give complete secondary balance in the multi-cylinder in a line engine both A and B. When the primary direct crank reciprocating engine makes an angle theta with the line of stroke, then the secondary direct crank will make an angle of when the line of stroke is 2 theta. For a twin cylinder V engine, crank position for primary reverse crank and secondary direct cranks are shown in the given figure. The engine is 30 degrees V engine. 30 degrees is the V engine is there. A body is said to be under forced vibration when no body vibrates under the influence of the external force. When no external force acts on a body after giving an initial displacement of the body to have a free vibration, this is the true. When there is a reduction in amplitude over every cycle of a vibration, then the body is said to have, this is the damped vibration. Longitudinal vibration is said to occurs when the particles of the body moves parallel to the axis. When the particles of your body moves perpendicular to the axis, the body is said to have, this is the transverse vibration. Torsional vibration is said to occurs when the particles of your body moves in a circle about axis. When a body is subjected to longitudinal vibration, the stress induced in the body will be tensile or compressive stress. This is the correct. When a body is subjected to transverse vibration, the stress induced in the body will be bending stress. The stress induced in a body will be shear stress when it is subjected to torsional vibrations. The natural frequency of free longitudinal vibration are equal to dash any one of these. The natural frequency of free transverse vibration is same as that of free longitudinal vibration. This is the right. A retype tachometer uses principle of dash transverse vibration. A simple spring mass vibrating system has a natural frequency of Fn is the spring stiffness halved and the mass is doubled, then the natural frequency will become Fn by 2. A machine mounted in a single coil spring has a period of free vibration and Tp if the spring is cut into 4 equal parts and placed parallel and machine is mounted them, then the period of free vibrations of the new system will be Tp by 4. The equation of free vibration of a system is d square x by dt square plus 36 pi square x equal to 0. The natural frequency is 3 Hz. For a swing mass system shown in the figure, the frequency of vibration when the more similar swing is added in a series shown in the figure. This is the This is the option is the Fn by root 2. A shaft of mass stiffness of is fixed one end and carries mass and other end is the natural frequency of the longitudinal vibration is equal to 1 by 2 pi root of s by m plus mc by 3. A shaft of mass stiffness fixed one end carries which mass at the other end, the natural frequency of the transverse vibration same as longitudinal vibration. This is the no. The natural frequency of free transverse vibration due to the point load acting over the simple supported shaft is equal to 0.4985 root delta. The natural frequency of free transverse vibration due to the uniformly distributed load acting over a simply supported shaft is dash 0.5615 root delta s. The natural frequency of free transverse vibration of a shaft fixed both ends are carrying a uniform distributed load 0.57 by root of delta s, where delta s static deflection. Shaft fixed both and carrying uniform distributed load. This is the true. The critical speed of shaft in revolution per second in a the natural frequency of transverse vibration is same. The critical speed of shaft depends upon, this is the mass and stiffness. The mass and stiffness. This is the The factor which affects the critical speed of the shaft is all of this above. The danger of breakage, the vibration is maximum near the critical speed. The rotating shaft tends to vibrate violently at a whirling speed is because dash resonance is caused due to the heavy mass of the rotor. The critical speed of the shaft with disc supported between the equal to the natural frequency of the system is dash transverse vibration. A slided shaft supported on a bearing extends to disc with a eccentricity from the axis of rotation. The critical speed of the shaft NC. The disc displaces second one of this same mass but mounted with eccentricity 2e. The critical speed of the shaft. The second case is NC by root 2. The equation of motion for a vibrating system with viscous damping d square x by dt square plus c by m into dx dt plus cs by m into x 0. If the rotor of this equation are real, the system will be dash over damped. If the rotors the equation are complex conjugate, the system will be typically damped. This is the no. The roots the equation are the system will be under damped. This is the complex conjugate. Critical damping is the function of mass and stiffness. In under damped vibrating system, the amplitude of the vibration decreases exponentially with the time. The equation of motion for a single degree of freedom system is viscous damping 4d square x by dt square plus 9dx by dt plus 16x equal to 0. The damping ratio of the system is dash 9 by 16. When mass of critical damped single degree of freedom system is deflected from the equilibrium position and released, then it will be oscillated with increasing time period. If the damping factor for a vibrating system is unity, then the system will be dash critically damped. In under damped vibrating system, if x1 x2 successive values of the amplitude the same side of the mean position, then the logarithmic decrement is equal to log of x1 by x2. Under logarithmic decrement and amplitude successive vibration is there in a geometric progression. Frequency of damped vibration with viscous damping is the frequency of undamped vibration. This is the less than. The overdamped system when distributed from the equilibrium position will not cross the equilibrium position is the right. A single degree of freedom system is given by m d square x by dt square plus c into dx by dt plus s into x of cos omega t. With the usual notations, it represents forced vibration with the damping. In forced vibration magnitude, damped force resonance is equal to the impressed is correct. In steady state forced vibration, amplitude vibrations at a resonance is damping coefficient is inversely proportional to the ratio of maximum displacement of the forced vibration to deflection due to the static force is known as this is the magnification factor. The ratio of the actual damping coefficient to the critical damping coefficient is damping. Yes, in vibrations isolation system, if W by Wn greater than root 2, then for all values damping force the transmissibility the ratio of the force transmitted with force applied will be less than unity. This is the true. In vibration isolation system is W by Wn less than root 2, then for all values of damping factor the transmissibility will be dash greater than unity. In vibration isolation system the transmissibility will be equal to the unity for all values of damping factor if W by Wn is dash equal to root 2. In vibration isolation system, W by Wn greater than 1 phase difference between the transmitted force and distributing force is dash 180 degrees. The transmissibility for all values of damping factor will be less than unity if W by Wn is there greater than root 2. If W by W is very high for body vibrating under steady state vibrations in a phase angle, values of damping factor will be tends to approach is the 180 degrees. If W by Wn is very low for a body vibrating under steady state vibration, the phase angle for the value of damping factor will tends to approach 0 degrees. When shaking force is transmitted through the springs, damping becomes determination when the ratio of frequency to the natural frequency greater than this is the root 2. If W by W and root 2 where W is the frequency of excitation and Wn is natural frequency of vibration, then the transmissibility of vibration will be dash 1. This is the 1, B is the W by W and root 2, less than 1 is the W by W1 greater than root 2, greater than 1 is the W by W1 less than root 2, tending to 0 is the W by W1 greater than or greater than root 2. The natural frequency of torsional vibration of the shaft is equal to 1 by 2 by root of Q by L. At the node point of the shaft, amplitude torsional vibration will be dash. shaft is the this is the 509 is the nodal point of the shaft amplitude for the torsional vibration will be 0. The two heavy rotation masses are connected. The shaft lengths L1 and L2 another diameter spin D1 D2 reduces the torsionally equivalent. Having uniform D1 equal D2, the shaft equivalent length of the shaft is L equal L1 plus L2 D1 by D2 whole power of 4 plus L3 of D1 by D3 whole power of 4. A torsional system with disk moment of inertia L1 L2 A is neglecting the inertia force equivalent to inertia of B. The speed of shaft is equal to A2 by G. If the two rotor system has shown in the figure, modes of the vibration is between I1 and I2 are nodal. If the node of shaft remains unaffected by the vibration, agree. A shaft carrying two rotors ends will have one node. A shaft carrying three rotors will have two nodes. They completed Tom. Thank you very much.